Hello everyone, in this video we're going to explore topic 8.1 average value of a function on an interval. Now, the mean value theorem for intervals. If the function f(s) is continuous on the closed interval, then there exists a number c in the closed interval a and b such that interval from a to b of f(s) ds equals f of c times b minus a. Now, if you divide both sides by b minus a, you're going to get this one right here. Alright, now we're going to demonstrate the mean value theorem for intervals using the symbol below. Alright, the graph of the function f(s) equals negative 1/2 s squared plus 8 is shown below. Alright, now if you calculate the interval from 0 to 4, right? 0 here, 4 here, of the function negative 1/2 s squared plus 8 ds using the calculator, the answer must be 21.3, right? Now, the right hand side right here, if you pick a value c between 0 and 4, so for example, I'm going to pick the points right here, alright? So c equals 2.3, right? And f of c equals 5.3, right? Why? Because you're gonna calculate f of c, which means f of 2.3 is gonna be negative 1/2 times 2.3 squared plus 8, right? So it's approximately 5.3, right? Now you're gonna take this value, you're gonna multiply by b minus a, which means 4 minus 0, right? So it turns out to be approximately 21.3, right? Now, the average value of a function. If the function f(s) is integrable on the closed interval a and b, then the average value of the function f(s) on that interval is 1 over b minus a integral from a to b of f(s) ds. Alright. Now, let's take a look at the first example. Let f(s) be 12 times s times e raised to the negative s. Find the average value of f(s) on the interval 2 to 5. Alright, so this one is a, this one is b, right? So you have the formula 1 over b minus a, the interval from a to b of f of s ds, right? So it could be 1 over 5 minus 2, interval from 2 to 5 of 12s times e raised to the negative s ds, right? Now you're going to bring up the calculator, since this one is the calculator active problem, right? Alright, you're going to hit menu, calculus, interval from 2 to 5 of 12 times s times e raised to the negative s, right? ds. Alright, now right here it's gonna be 1 over 5 minus 2, which means 1/3, right? And hit enter. It's right here. You need to convert this one to decimal, right? So it's gonna be menu, number, convert to decimal, hit enter. The answer is 1.46231, right? Now question B. Find the number c such that average value of f(s) is equal to f of c, right? So you have f of c equals this one right here, right? Which is this guy right here, 1.462, right? But the function f of s is right here, right? So substitute c for s, right? So you have 12c times e raised to the negative c equals 1.462, right? Now you're gonna print up the calculator. You're gonna hit on right here, go to the main screen, right? Hit graph right here. You're gonna input the first function, which is the left hand side right here. It's gonna be 12 times s times e raised to the negative s, right? Hit enter. It's gonna be right here, right? Now the right hand side right here, which is the horizontal line, right? So you're gonna hit tab, right? Hit 1.462 and hit enter. Alright, now you need to find the intersection, the interval 2, 5 right here, right? So you need to limit the domain, right? So you need to hit menu, number 4, Windows setting right here, s equals 2, s max equals 5, right? Hit OK. It's gonna be right here. Now you need to find the intersection between these two graphs, right? So you're gonna hit menu, number 6, number 4. Alright, move your cursor to the left, move your cursor to the right, then the intersection right here. C equals 3.3, right? Now let's move on to example number 2. Example number 2 is similar to example number 1. Alright, I'm gonna leave this one for you to practice. I'm gonna provide you with the key. The answer key for question A is 16. Now, answer key for question B, you have two values of C. C1 equals 8 over 3. And C2 equals negative 2. Now, remember, your domain is from 1 to 4, right? So you need to eliminate this guy. Your answer must be this guy, right? Now, let's move on to example number 3. The cows on a small dairy farm in northern Indiana are milked in the morning during a 2-hour period. Milk from the cows is pumped into a storage tank, and the volume of milk in the tank at time t is modeled by a strictly increasing twice differentiable function m, where m of t is measured in gallons and t is measured in minutes. At time t equals 0, there are 300 gallons of milk in the storage tank, which is right here. Value of m of t's at selected times t's are given in the table below. Now, question A. Estimate m prime of 70. Indicate the units of measures and explain the meaning of your answer in the context of this problem. Alright, so basically you're going to use the mean value theorem, right? You know that 70 is between 50 and 90, right? So you have m prime of 70 equals m of 90. Subtract m of 50. Divide by 90. Subtract 50, right? Now m of 90 is 3360, which is this guy. Subtract m of 50 is going to be 1640 over 90 subtract 50, right? 3360 minus 1640, then you divide by 40. The answer is 43 gallons per minute. Alright, now you need to explain, so you need to say that the amount of milk in the storage tanks is increasing because it's positive, right? By 43 gallons per minute at time t equals 70 minutes, right? Now let's move on to question B. Use the data in the table to evaluate the interval from 0 to 120 m prime of t dt. So we have the interval from 0 to 120 of m prime of t dt. It's going to be m of t evaluated from 0 to 120 by the fundamental theorem of calculus, right? Remember, we have integral from a to b of f of s ds equals f of s evaluated from a to b. So it's going to be f of b minus f of a. Alright, so keep that in mind. So you have m of 120 subtract m of 0, right? But m of 120 is 4250 and m of 0 equals 300, right? And it's going to be 3950 gallons, right? Now, using the correct units, interpret the meaning of this guy right here in the context of the problem. So you need to say that 3950 gallons of milk have been added to the storage tanks from t equals 0 to t equals 120 minutes. Now let's move on to question C. Use a right Riemann sum with 4 subintervals indicated by the data in the table to approximate this guy. Alright, now we're going to look at the table right here. 4 subintervals. So from here to here, 1. From here to here, 2. From here to here, 3. And from here to here, 4. Right? So we have 1 over 120. Integral from 0 to 120. M of t dt equals 1 over 120. Right? Times, since we use the right Riemann sum, so we're going to look at the right one right here. And the width is from here to here 20, right? The width right here 30. This could be 40. This could be 30, right? And the height is right here. Right? So we have 20 times 780. Right? Plus 30 times 1640. Plus 40 times 3360. And the last one, 30 times 4250. Alright, now I'm opening up the calculator. You're going to input this expression on the calculator, right? Then you hit enter. You're going to convert this one to decimal. Hit menu, number, convert to decimal. Hit enter. The answer is 2722.5. Alright. Now explain the meaning of this expression in the context of this problem. And you need to say the average number of gallons of milk in the storage tank from t equals 0 to t equals 120 minutes is approximately 2722.5 gallons. Now we need to answer this question. Does this approximation overestimate or underestimate the exact value of 1 over 120? The integral from 0 to 120 of m of t dt. Explain your reasoning. You need to say that this approximation is an overestimate because we are using a right Riemann sum approximation on a function m of t that is increasing on that interval. Look, the given function is strictly increasing, right? Now let's move on to example number 4. This is the AB Calculus AB BC 1999 free response question 3. The rate at which water flows out of a pint in gallons per hour is given by a differentiable function of times t. The table above shows the rate as measured every 3 hours for 24-hour period. Now, question A. Use a midpoint Riemann sum with 4 subintervals of equal length to approximate the interval from 0 to 24 of r of t dt. Using correct units, explain the meaning of your answer in terms of water flow. Alright, so this one is the midpoint Riemann sum and 4 subintervals. Right? So you see that the first interval should be right here, right? The second interval should be from here to here. The third interval should be from here to here. And the last interval should be from here to here, right? Now we need to find the width. The width is going to be 8 times, right? And the height should be the midpoint right here, right? It's going to be right here. From here, it's going to be right here. This guy, right here. And this guy, right here, right? So, the interval from 0 to 24 of r of t dt equals width times height, which is 10.4, right? Plus 6 times 11.2. plus 6 times 11.3 plus 6 times 10.2, right? I'm going to bring up the calculator. Alright, so I'm going to factor 6 out, right? So I have 6 times parenthesis 10.4 plus 11.2 plus 11.3 plus 10.2, right? Hit enter. The answer is 258.6 gallons, right? I need to explain the meaning of your answer in terms of the water flow. You need to say that this is an approximation to the total flow in gallons of water from the pipe in the 24-hour period. Now let's move on to question B. Is there some time t from 0 to 24 such that r prime of t equals 0? Justify the answer. Alright, so we're going to use the mean value theorem, right? Now, by the mean value theorem, we have r prime of t equals r 24 subtract r 0, right? Over 24 minus 0, right? Now, to get this one equals 0, right? It means the numerator right here must be equal to 0, right? So you need to conclude that r24 minus r0 equals 0, right? Then I'm going to add r0 both sides. So I have r24 equals r0, right? Now we need to check to see if this one happens, right? So we look at the table right here, r24 and r0. r24 equals 9.6, r0 equals 9.6, yes. The mean value theorem guarantees that there exists a number t between 0 and 24 such that r prime of t equals 0. Now let's move on to question C. The rate of water flow R of t can be approximated by Q of t equal this one. Use Q of t to approximate the average rate of water flow during 24-hour time period. Alright, now average rate is the keyword, right? So question C, we have average rate of flow equals 1 over 24 minus 0. The interval from 0 to 24 of this one right here, right? then you're gonna hit the calculator, right? So you're gonna hit menu, calculus, integral, hit enter. Now don't forget to divide by 79, right? So you need to divide by 79. So the answer must be, you need to convert this one to decimal, right? The answer is 10.7848, right? Now let's move on to example number 5. AB, calculus AB 2004, free response question 1. Alright. Traffic flows is defined as the rate at which cars pass through an intersection measured in cars per minute. The traffic flow at a particular intersection is modeled by the function f below, where t is measured in cars per minute and t is measured in minutes. Alright. Question A. To the nearest whole number, how many cars pass through the intersection over 30 minutes period? Alright. Now remember, this one is the rate, right? So when you take antiderivative of this one, you get the number of cars, right? So question A right here, you have interval from 0 to 30, right? Because it say over the 30 minutes period, right? From 0 to 30 of 82 plus 4 sine t over 2. Alright, now you're gonna bring up the calculator. You're gonna hit menu, calculus, integral from 0 to 30 of 82 plus 4 sine of t over 2, right? Which means s over 2. Right here, you're gonna put ds, hit enter. Right, now you need to convert this one to decimal, so hit menu, number, convert to decimal, hit enter. Alright, now question B. Is the traffic flow increasing or decreasing at t equals 7? In order to know if the traffic flow is increasing or decreasing, we need to take the first derivative of this one, right? So we have f prime of t equals derivative of 82 equals 0, right? Derivative of this one, we need to use the formula sine u prime equals u prime times cosine u, right? So it's going to be 4 times 1/2 times cosine of t over 2, right? Now we're going to substitute 7 for t, so we have f prime of 7 equals 4 times 1/2 is going to be 2 cosine of 7 over 2, right? Now you're going to bring up the calculator. You have 2 times cosine of 7 over 2. Hit enter. Convert this one to decimal. Hit menu, number, convert to decimal, hit enter. The answer is negative 1.872, right? Which is less than 0, right? So if it's less than 0, you need to say that the traffic flow is decreasing at t equals 7. Now let's move on to question C. What is the average values of the traffic flow over the time interval 10 to 15? Right? This question very simple, right? So we have the interval from 10 to 15 of f of t right here, which is 82 plus 4 sine t over 2 dt. And don't forget 1 over 15 subtract 10 right here, right? Because this one is the average. I'm gonna hit the calculator. So 1 over 5, right? Times the integral from 10 to 15 of 82 plus 4 times sine of t over 2, which means s over 2, and ds right here. Hit enter. Now convert this one to decimal. It's going to be 81.899, right? The units right here should be cos per minute. Now let's move on to question D. What is the average rate of change of the traffic flow over the time interval 10 to 15 minutes? Now, you need to know the difference between question C and D. Question C is say the average value, right? Question D, the average rate of change, right? So the average rate of change is going to be, remember, f of b minus f of a over b minus a, right? So keep that in mind. A equals 10, b equals 50 right here, right? Now f of b is going to be this one right here. So we have 82 plus 4 sine of 15 over 2, right? Minus 82 plus 4 sine of 10 over 2, right? Over 15 subtract 10, right? So it's going to be 82 subtract 82 is going to be 0, right? So I have 4 times sine of 15 divided by 2 is going to be 7.5, right? Subtract factor 4 out is going to be sine of 5, right? Over 5, right? So I'm going to bring up the calculator. So I have 4 times sine of 7.5 subtract sine of 5, right? Hit enter. Then you need to divide by 5. Hit enter. The answer is 1.517, right? Unit should be cos per minute square, right? Because the unit of the function f of t right here is cos per minute, right? Then you divide by times right here, which means divide by minute. That's why you have minute square right here, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand